Kerbal Klassroom! Welcome to class. In this episode, we'll learn about Newton's cannonball and how to get to orbit. Today's episode is called Newton's Cannon because there is a thought experiment that Sir Isaac Newton, devised where he said, if I stick a cannon, like an old school cannon, on top of a really high mountain and shoot it, what will happen with the ball? Or will it go off forever? Or something else. And he said that based off of the speed that you shoot the ball out of the cannon, it will go a certain distance and plunk, or a slightly further distance and plunk, or even slightly further distance and come around and hit the cannon right in the back. As long as there's no atmospheric drag, of course. So the mountain has to be outside of the atmosphere, and the final distance that you shoot it has to also be out of the atmosphere. And if you shoot it fast enough, you can get even farther. And if you shoot it super fast, you have what's called a escape from the planet that you're currently on. So we're going to do the cannon experiment in Kerbal Space Program today and learn how to orbit. And we'll come back to this in a minute. Okay, so first we need a ship that can get to orbit. We built a quick ship last time that had a heat shield and a parachute and a decoupler and a liquid fuel tank and a swivel engine. Today we're going to add a decoupler to the bottom of that. Let's see, where's the part that I'm looking for? Structural, there we go. This one. Guess an orange tank. And where is the twin bore? There it is. Alright, we're going to have a nice big engine to get us up into space, and then we're going to turn and practice what is the Newton's cannon experiment. Check our staging. And let's go ahead and bring some solar panels just in case we stay out there for a little bit longer. Launch. Okay, we're going to press T to turn on the SAS. We're going to press Z to get the throttle all the way up, and we're going to press space to go to space. We have about 2 gravities of acceleration, so every second we should be going up about 60 meters per second, fighting gravity. Now I'm going to press M and get all the way to the map and just kind of follow the gimbal and keep it at the center mark. That shows we're headed straight away from the center of the planet. We're going to watch our app out, so we want to get a nice, I don't know, about 200,000 meters up in the air or into space, so that we can mimic being on top of a mountain that is outside of the atmosphere and then fire what would be a really nice cannon. There we go, about 200. And let's see how quickly we're getting through the atmosphere. Oh, we were starting to burn up a little bit. But we're already at 53 kilometers, so we're pretty near the beginning of space. Let's go ahead and decouple. We don't really need this particular section for this, and so let's keep it nice and light. We're in space now, so let's go ahead and extend our solar panels. We're right-clicking on these solar panels because they're just like any part. You can right-click and see what actions you can do. And now our solar panels, if you right-click on them, show that they're receiving sun, and our electric charge will stay nice and clean. Now when we get to the top of this, we're going to want to turn. Let's go ahead and warp a little closer to the top. You can see as we get closer and closer to the top that we're losing kinetic energy and we're gaining potential energy. Our prograde vector is also starting to turn away from directly under the and we have a nice ComSat link to Kerbal Space Center's tracking station, so you can see where straight down is with this nice green line for us. When we hit this apoapse, we're going to pretend we're a cannon, and let's go ahead and face the direction we want to by pressing D to point all the way to the horizon line on the gimbal. It's between the orange and blue. As the prograde vector gets, as we get close to the apoapse, prograde will match with that particular spot. And let's go ahead and just warp about 30 seconds into the future and watch. This prograde vector is starting to angle towards the horizon line. Now let's go ahead and save the game, and what will happen if we add just a little bit of cannon? Turn, oh, I need to stage. Again, we are facing directly tangent to the planet. So if we do just a little bit, we would continue and fall here. If we keep firing nice and directly, like a, imagine like this green bar being a T, and we're going in this direction, and we want to make a nice T for tangent. If we continue burning, we keep falling a little bit further, a little bit further, a little bit further, a little bit further, until if we kept falling, we would stay in space. Now, Isaac Newton also taught us that an object in motion stays in motion, and an object at rest stays at rest. Well, we have particular inertia to go this direction. The planet is pulling on us at every particular spot, and that's warping what would be a line into an ellipse. Now, it's an ellipse rather than a circle because it is not perfectly circle. If we wanted to, we could actually come out to one of these two spots and circularize, or we could rotate the circle. We'll go into how to do a little bit more orbital maneuvering when we're in our next episode. This episode, I just wanted to teach you how to get to space. So if you use Newton's cannon method, go straight up past 70 kilometers and then fire directly tangent to make a T, an invisible T, and go burn towards the direction you're well, in this case, the planet is rotating and gave you some inertia in that direction already. You could have burned the other direction, and that would have been fine. You just would have been traveling in this direction rather than this direction. And let's look at Wikipedia real quick. This is Newton's Cannonball thought experiment described. He said if we go all the way to the top of this mountain and just drop it rather than launch it, it would come straight down. If we launched it with a little bit of velocity, in this case 6,000 meters per second, and again, this is Earth. Earth is a different size than Kerbin, and different orbital speeds are needed to actually achieve orbit. In Kerbal Space Program, we needed about a little over 2,000 meters per second in order to have a nice orbit. And on Earth, I think you need closer to about 8,000. And down here it says 7,300 if you were launched from this particular mountain, although I think that the normal low Earth orbit objects like the space station, I think, are probably a little bit higher than this hypothetical mountain. Anyway, so you can see up here at the top right, if you had launched it just a little bit, it would go to the spot at A. And if you launched it a little bit faster, it would go to B. And if you launched it even faster, it would have a nice circular orbit. If you launch it even faster, it will have a nice elliptical orbit. And if you launch it even further, it will have a hyperbolic orbit, which is called an escape orbit. That means that you escape the sphere of influence of the moon. Another thing that we can look at is the gravity well. You can imagine that at the bottom of a spot in a trampoline, pushing down with your feet, that the point where your feet are could be a planet, and you need to kind of circle the drain with like if you're at a theme park, sometimes they have little coin drops that go down. You release them and they circle like this. Well, if you are in orbit, you actually will be maintaining that nice orbit rather than circling, because it's not quite exactly the same idea as that, but it's very similar. Anyway, if you for your homework today, look at Newton's cannonball and gravity wells on Wikipedia and learn a little bit about the science of how we achieve orbit and stay in orbit rather than falling down. You'll understand how you stay in space. In order to get back down, we fire in the opposite direction, so in this case retrograde, and we reduce the orbit. It's like pushing the cannonball back into the cannon after it's been fired. Now it's making this orbit smaller, and we run out of fuel. If I jettison my lower stage, I would get into orbit, or deorbit, and get back down to the surface. I hope you guys downloaded the demo last time and are considering buying the game. Here's a link, and feel free to subscribe, like, and comment. Let me know what you would like to learn in your next lesson.